we are recording this as well now. Technical difficulties.
I think we're recording. Yep, we're recording now.
Excellent. We're now recording again.
All right, they should be able to see the screen.
Okay, great. So yes, we're going to be, you guys are going to need to do the careers on your own. We're going to be covering a couple of the vocabs during the game tonight, so pay attention to that and write down definitions or just remember it for later, but you will need to write them down. And then also remember that in 2 weeks, you guys will be doing your presentations on the fossil you guys have, the state fossil from this list, or if your family is from a different state that you'd like to do from as well. So just keep that in mind as we move forward. All right, so we are going to be doing requirement 5, which is the Earth history option. So we're going to get into that. So the first thing you guys need to do is you're going to look at this geological chart and also determine kind of when some of the rocks in Georgia would have formed according to this chart. So you guys jot down a couple notes here if you want. This is also on the website. You guys are going to need to draw this out, or at least draw a little bit of it out for the requirement, but we're not going to leave a lot of time to draw it here because again, it is on the website. So if you look down at the orange arrow, Georgia's oldest rocks are right in between the Cambrian and Proterozoic era. So that means that we have some really, really, really old rocks as far as rocks goes. That's about 2.5 to 2 billion years old. So that's when our first rocks, the crust, is going to be forming. And that you're going to find a lot more on the coast because, again, a lot of Georgia was underwater during this time for much of its history. As you can see in the green arrow, that's when the water recedes. So for about 2 billion years, another 2 billion years or so, we're going to have water that's covering most of Georgia in the inland sea, which is what's going to be in between the landmass of Pangaea during that time and as it splits apart as well. So right around the Miocene, we're going to get the water receding. And that's why if we do have a lot of fossils, it's either going to be trilobites, which are down all the way at the Cambrian, or Cenozoics, your big mammals, which are up at the Miocene. Everything else is going to be shark's teeth and things like that, again, from when it was underwater. All righty, so we're going to go over the theory of plate tectonics. So does anyone have a good idea of what the plate tectonics are without reading my slides? Just go ahead and blur it out if you do. Nobody attended 7th, 8th grade? No?
Plate tectonics are like different parts of the earth, like each continent is like floating on molten rock.
Exactly. Yeah. So that's a good bit of it. Yeah. So Earth is separated into Earth's crust is separated into lots and lots of different pieces, and those are all going to be floating on top of the mantle, which again, 8th grade, 7th grade science is floating on our crust is floating on top of this lava field that makes up most of the Earth, and it's always moving, always in constant motion. And that's where you get earthquakes and mountains and valleys from rubbing up on each other. So here is a map of the Earth. You can see the continents, and then you can also see the different plates. So what can you tell me about, let's look at the California area. Why are there so many earthquakes in California?
Because there are two plates colliding, the North American plate and the Pacific plate.
Exactly. So there's two big plates that are right there. And then there's also that little plate up there. It's in the ocean up kind of near Washington and southern Canada. But that's going to cause a lot of aftershocks as well in the ocean. So a lot of the damage from earthquakes that happen is from aftershocks and things like that, where it's reverberating across from the epicenter of the actual where the plates are rubbing at that point. And so those reverberations are what causes the damage. So having 3 plates right there is really a big issue. And that's also, of course, where we get the big mountains that are in that area. That's how those had formed as well. So that's always good to kind of keep in mind when you're studying the Earth, where the different plates are. Alrighty, so fossilization. So as you can see with my wonderful illustrations here, And probably the one on the bottom is the one you're more familiar with from textbooks and things like that. But fossilization starts with something dying, obviously. So most of the life on Earth is not fossilized. In fact, I saw somewhere that you have a better chance of being struck by an asteroid than you do being fossilized, which didn't really work out well for the dinosaurs who did get struck by the asteroids. But you're going to see this rapid burial process right after death. And so after they are buried like that or covered in water, it has to happen really quickly. Otherwise, the decay process will just erode it right away. You're going to get something called pre-mineralization. So that's when the bone and all the tissue actually gets replaced with rock. Now, in a lot of cases, it is just going to be normal rock and sandstone. If you look at my camera, this is an ammonite. Now, this ammonite here is a mold ammonite. So basically, the ammonite shell is hollow, and sand and debris is going to go into that hollow shell and form this fossil that we see here, and that's going to harden. Now, in other cases, more rare cases, you're going to get ammonites that look like this. Now, it's going to be hard to see, but this is what we call an agatized ammonite. So that means that instead of just normal debris and rock and sandstone, it's going to be a really pretty crystallized structure. And so this is actually an opal. It's a fire opal. When you look at it with different sunlight, it becomes translucent. That's just making the picture.
Yeah, it's not working right.
It's going to be, looks like there's fire coming out of it, which is super cool. So that's one of the many cool things about fossilization, and especially the pre-mineralization, is that you never really know what you're going to get. And then, of course, millions or thousands of years later, depending on when you died, erosion and exposure is going to get rid of a lot of that dirt and debris around you and leave behind just the solid material that formed with fossils. So that's when we get to the final part where you're able to actually find them in the ground or in the ocean when they wash ashore. Okay, so this is going to be part of what we're going to be doing during the game tonight. This is going to be a lot of the vocab, benthonic, pelagic, littoral, lacustrin, open marine, brackish, fluvial, lowen, protected reef. A lot of these probably aren't that familiar to you, but don't worry, you will learn a lot more about them during the game. And a lot of the times they're going to be they're going to be easy for you to figure out just by the name of it.
We've got other fun stuff during the game too, so
Yes.
we'll be all this.
Don't worry, it is a Shumpert production, so there's always some fun things in there. Okay, so in order to, so as I told you last week, we're going to be showing you several things from my collection. 20, in fact. You only need to draw 15 of them. But part of this is you need to also, with those 15, you need to tell me kind of how they were fossilized. Yes, David, go ahead.
What requirement are we on now?
We are on 5D.
5D5.
5D5. So it's the option D under number 5 and then number 5 in number D. They really tried to make it as complicated as possible for you.
It sounds like they're saying 55, but it's like...
Yeah, 5D as in dog, 5. All right. So you guys are going to need to be able to tell me if the things I show you are original remains or the other things we're going to cover. So original remains, these are going to be things like bones, teeth, shells that have actually, those are the things that have been pre-mineralized. A lot like the different teeth I'm going to show you, where the rock actually replaced the bone itself instead of just filling in holes like the ammonites. Now an external mold, as seen by this really poor quality starfish, is formed when, let's see, in this starfish's case, he was sitting there, sea star's case, he was sitting there and rock and sand covered him up, and then he withered away as life does, and then what was left was just his imprint of when he was once there. That's what you're going to see a lot of the different footprints and things in as well. That's where a lot of those are formed. Now, an external cast, that's when an imprint fills with other sediment and debris. So that's if Mr. Sea Star was sitting there and then other things filled in his gap, much like these ammonites here. Now, an internal cast, like the ammonite I showed you, is when the hollow shell gets filled with all of this debris and it gets trapped in there and then it hardens into the rock. And so that's kind of like a mold of what it would be, not the actual animal. And then there's carbonization, which creates some of the coolest fossils. And that's, you're going to see this a lot with fish and insects, where carbon is going to be in the plants and things that the animals will have eaten. And a lot of that other organic material is going to wither away, where the carbon is going to just stay put. And that's what creates the bone structure and the different fins and things that you'll be able to see in this. Now, petrification. This you're going to see in bone and wood, really just porous material that has lots of holes that allow different sediments to fill in. And that's what's going to be replacing it. And it's going to be a much longer process to petrify something than it is to fossilize, even though they both take quite a while. There's not going to be a lot of petrification in these things that I'm going to show you. All right. Now we're going to be doing the fossil identification fun of this. So I'm going to turn on the other webcam so I can point something down for you so you can see it a little better. There we go. Okay. All
So
right.
you want to leave that up?
Yeah, we'll leave that up.
Because otherwise you'll be able to see it better, what you're showing.
Oh, sure. Okay. Then go ahead and get rid of it then. Okay. So the first thing I'm going to show you is a La Brea tar pit beetle. Now, as the name suggests, these are from the La Brea tar pits in California. And here's the beetle right here, the shiny black in the midst of all the other black. So the black that you're going to see here is the actual tar from the pit itself. And then this is the actual beetle that was carbonized with the other tar. So it kind of formed around it and then hardened as well. So that is the tar pit beetle. I'll give you a little bit of time to write it down. Yes, David?
So we are supposed to draw these and
Correct.
what else?
So you're supposed to draw these and then go ahead and write what you think the process of fossilization was for this one.
And write what it is.
Yes. So write down what it is because you'll need to show me later.
I wish I had a fossilized beetle.
I don't remember what the first three were.
That's okay.
This
This is the first one.
This is the first one, so don't worry.
No. The first three,
Okay. So the different processes are, we've got petrification. I don't remember what order they're in.
remains.
So we've got original remains. Oh, here we go. Fancy cheat sheet. Original remains, external mold, external cast, internal cast, carbonization, and petrification. So I'll give you this one. This one is original remains. But the others you
Thanks.
get to figure out on yourself, on your own, I suppose. All righty, everyone good?
So the tar actually caught him very, very quickly, and the tar keeps him preserved very, very well. So all the things that you'll find that have been preserved in tar are going to be original remains.
For the most part, yes.
For the most part.
Alrighty, and you guys don't have to do crazy detail on this one, or on any of these, of course.
And how many can they skip?
You can skip 5 because I'm showing you 20. You need to draw 15. Alrighty, our next thing here is a Lebanese flying fish. So these are super cool and very tiny. These are found in Lebanon. And as the name suggests, they are flying fish, much like the flying fish we have today in our oceans. These are some of the earliest ancestors. So their big fins on either side allow them to glide out of the water. But these would have been doing so on a much smaller scale, much like minnows today. So if this camera was a little bit better, here, let me try to get a little closer. You can't really see it well, but you can see all the different little bone structure and wing parts of this fossil here. And so that makes it a really cool one.
Hey, Avery,
Yes.
where'd you get all of these fossils?
I have very good friends and connections who are fossil collectors that I purchased a lot of these from. And then a couple of the ones I show you, I have found myself as well, but this is not one of the ones that I've found.
Cool.
if you are interested in collecting, you can email me afterwards and I can send you the link to the gentleman where I get a lot of my fossils from. He has great starter sets as well, if you're interested in that, or just to browse. So if you're interested in that, feel free to email me and I can help you get in contact with people who can help you begin that.
All right.
Alrighty, we're gonna move to the third one now. So this is from the Santa Ana Formation in Texas. And this is where we're gonna get a lot of cool insects from the Santa Ana Formation. So this is actually a honeybee that's been fossilized. And all of these little tiny lines throughout here, those are going to be little larvae of different insects as well, most likely different nymphs from dragonflies, different flies, mosquitoes, things like that. So that's what all of those little lines are. And then of course the honeybee in the bottom. The Santa Ana Formation is one of the few places where you can find really nicely preserved insects like this. You guys are mostly familiar with seeing insects probably in amber. That's where you're going to see them a lot in other places. But stone, one of the few places you can find them is Santa Ana. So that makes these really cool. Alrighty. Oh, yep. I got it. Alrighty, so the next one, this is a claw from an Erematherium. Now, an Erematherium is this guy right here for reference. It is a giant ground sloth. Now, these giant ground sloths did live in our area all the way up to North Carolina, even to Pennsylvania, and then down into Florida as well. But this is going to be one of the ends of their claws here. They use these to forage, things like that. When you hear of the big caves in Tennessee and North Carolina, where there's a lot of coprolite, that's dinosaur and prehistoric poop found in caves, that's going to be these guys here. So that's where you're going to see a lot of these Erematheriums.
What is it called again?
It is an Erematherium, E-R-E-T-H-U-R-I-U-M. I'm a bad speller, but just sound it out.
Giant ground sloth.
Yeah,
Works really well.
just do giant ground sloth. That's easier.
How big are these ground sloths?
So these giant ground sloths, these particular ones can be about as big as a car. If at full adults. Other species, the ones that are in Africa, megatheriums, those could be even bigger.
I've never heard of a sloth as big as a car.
Yeah, they're very cool. One of my favorites, I think.
Are they still slow?
Depends. The bigger ones, not really. No, they're about the same size. Sorry, not same size, same speed. They can probably move the same. Probably as you or I, a little slower, but they were big enough that they didn't need to conserve a lot of energy, unlike their cousins in South America.
Oh, okay.
Yeah.
Depends if they're hungry or not.
Yes, there you go. If they're chasing the wild bush. Alrighty. So our next one is a juvenile cave bear jaw. So these guys were around the same time as the sloths. And what's interesting about this jaw is you might look at it and you say, wow, Avery, there's a lot of teeth missing, but actually all of the teeth are there. If you look into the jaw, there's a tooth, and all of these holes here have teeth as well. They just haven't erupted yet because this is a baby. So it's so young that all of its teeth hasn't come in. So the one you can see right here, and then a canine up here, those show kind of where it was in its life stage, that it was just beginning to grow its teeth. So probably just finishing suckling from the mother, so nursing, because again, these are mammals. So they were just growing into their meat teeth and out of their milk teeth. Alrighty. All right. Now this is a Trionyx turtle shell. So a Trionyx is a species of soft shell turtle. So whereas a lot of the turtles that you'll other see in museums, you'll see the full shell. These guys, the soft shells, they didn't have bone surrounding the entire shell because they were soft shells. So that would be a lot of cartilage and things like that that would dissolve over time, leaving just these bony rivets going out to the side. So this is a carapace. So you can see all the different indentations here from where it used to be attached to the body. And then all of these coming off of it to kind of support the frame of the shell. And then I'll flip it over for you as well. See the smoothness of this side. It's very different from the other side. And I'll flip it back for those of you drawing.
So we're supposed to be like drawing these, saying their name and.
Yep. Drawing them, their name, and then what type of fossil classification they are. And if you miss one or I'm going too fast, I can of course slow down for you. But this will be on the website as well for you to go back. And the video is recording. Alrighty. This next one is one that I found myself. This is a rabbit bone from the Pleistocene era, so about the same time that these giant ground sloths would be going about their day. This is a smaller rabbit, well, larger rabbit actually. This is quite a large size for a rabbit bone even today. But this is one of the cooler things I've found. As you can see, it's hollow, which it wouldn't be normally if it was on a rabbit. That's usually what we see with bird remains. But this used to have a lot of marrow in it, and that would have dissolved as well because it's not really, because it's a more fleshy material rather than the hardness of the bone.
What part of the rabbit is that from?
You know, that's a really good question. It is harder to tell, especially with smaller mammals, but I believe this is more of a leg bone, probably a front hind leg, with this part being attached kind of to the shoulder, with this being a shoulder blade. But it is.
What was that again?
This is a rabbit.
A rabbit what?
Rabbit arm bone.
Okay, thanks.
No problem. Alrighty, so our next one is trilobite tracks. So the trilobite that you see right here would not, he was not found with these tracks. This put here kind of as a demonstration of what it would look like. But these two lines and then curving down here, those are his tracks. Kind of think of him as like a giant millipede with all the different legs underneath him going throughout the day in the sand and the substrate that he was underneath. So that's him leaving these tracks all along this sand here.
Trilobites are cool fossils.
They are. They're some of my favorites. I have quite a many trilobites. They're also a really good one for beginning collectors as well. That you can find a lot of ones for all different kinds of price ranges. So they're a very good starting fossil, just like the ammonites I showed you as well.
I think I have two small ammonite shells.
Very cool.
They're really, really small though.
Mm-hmm. That's again, it shows you the difference between ammonites. I've seen ones probably as small as you're talking, and then also as big as a person as well, sometimes 6 feet tall. So it really shows the range of different species and their ages as well. So it's a very cool and very developed animal. Alrighty. Now this next one you'll probably be a little more familiar with. This is part of the frill from a triceratops. So this would have been where it's nice and curved here at the top. That's going to be the top of the frill. And then this would go down into the body. So this is probably one of the top pieces in between where the different horns and spikes would have been. And so all of these different grooves here, these are called blood grooves. So unlike a lot of the different moose and elk that you see with antlers and things, the Triceratops frill was not meant to fall off. So all these grooves would be where the blood vessels and the different tissue would be, so that it could support this frame and always keep it growing as well. Take my watch off here. It's rubbing on the desk. Alrighty. This next one might be a little bit hard to see, but there are a couple pictures of it to make things better. But this is Dominican amber. So as the name suggests, this is amber that was found in the Dominican Republic. There's tons and tons of insects in here. I find more every time I look at it with my magnifying glass. Some of the cooler ones are pictured here. That's a stinging ant right here. And then that is a mosquito right there as well. So you've got several stinging ants. There's a mosquito, a spider. There's a bit of a moth in there where you can see the wing structure. Several mites, all kinds of different things. I find new things each time I look at it.
Amber is really cool because it's like a capsule of
Yes,
time.
it is. It's very cool. They find all kinds of wonderful things in amber, from lizards to birds to even a bit of a dinosaur tail at some point with all the different feathers. They found that one recently. That one was very cool. Kind of gave proof that dinosaurs had feathers. They had thought about it for a while, but this was kind of the first conclusive evidence that there was some. So amber, as you said, it's really just a time capsule. So it's a really cool way to see back in time.
Is that amber you have? Is that one polished or did it come like that?
Yeah, so it is polished. Yes, you're correct. A lot of amber that you're going to find is kind of like this. It's obviously a picture, but it's going to be more hazy, but it is a lot more hazy amber. I have some pieces that are very hazy, but yes, it is definitely polished. So you're correct on that. Because when
Just
you
don't
think
extract any DNA from them.
yeah, no, not yet. I'm saving that for when I can actually house the dinosaurs. You don't want to put the cart before the horse, you know, or before the gallimimus.
Oh,
Ba-dum-bum.
Yes, but bump. All righty. This is a whale vertebrae. So it's about the size of my hand, as you can see. So fairly big, probably about 5 inches or so. So this would have been one of just hundreds of vertebrae that would have been part of these big whales. Most likely, if it's a toothed whale at this point, baleen whales evolved much later in time than this would have been. And so you've got probably kind of whale similar to the Basilosaurus, like I showed you last week, or even the orca today. I'll rotate it around for you. So this is only half of a vertebrae. It is still big, but it is only half of a vertebrae.
It's so cool to think that that was a part of an animal so long ago.
It is. That's part of the reason I really just love collecting fossils and things, just having pieces of history.
And that thing's
Wow.
really big.
Yeah.
How many vertebrae are in a single whale?
It really depends on the whale. It can be anything from 20 to 30 for your dolphin size things, all the way up to 50 or so. Most of the time, the number of vertebrae don't change. It's the size as well. So this one is a much bigger animal. Although the vertebrae do obviously change in size. I mean, number as well.
So, like, imagine maybe 60 of those because it's like cut in half.
Exactly. And of course, that one's probably one of the bigger middle ones. And so as it goes even higher up, it's going to be getting even bigger as it has to support the skull, and then a little bit smaller as it supports the tail. This is a juvenile woolly mammoth tooth. So woolly mammoths, they shed their teeth 6 times in their life. The first time is just a little milk tooth, which is probably about that size. So this is going to be the second or third teeth that they're ever going to get in their life. And it's going to be much smaller than some of the big ones you'll see in museums today. That can be about a foot or so, 1.5 feet long.
Where's the tooth?
What is it?
Yeah, like what part of the rock is the tooth?
So this, it's hard to tell because with mammoths, they don't have canines or incisors or molars like we think of with people. It's more of an elephant where they have like 4 or 6 teeth in their jaw, depending on the species. And they're all kind of going to look like this, where it's all just grinding matter and things, because all they have to do is collect the grasses and shrubs that they are going to eat.
So that whole thing is the tooth.
Yeah, so this whole thing is the tooth. It's one tooth.
Show the different sides.
Wow.
Here's where it would have connected to the bone and to other teeth on this side. This is where, if it was a more complete tooth, it would have the roots coming out of it. So you can see an indentation here, 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 and here, kind of like the stereotypical cartoon tooth that comes off with the 4 roots that you've seen. That's going to be those roots. And then this is the other side of the tooth where it would rub against just the bone and other teeth as well.
All the different casts, isn't there one that's like an imprint cast, like a footprint or something like that?
So that's an external mold. This one, I'll give you a hint, is not an external mold. It's not a mold. Alrighty. Next thing is a bonus. It's a 2 for 1. So you can draw either one you'd like or both. These are Glyptodon scoots. Now, a Glyptodon is an armadillo, giant armadillo like this guy. He's going to be about half the size of, well, not about the same size as our ground sloth if he was on all 4s. Rather than on 2 legs as he was shown in the last one. But this guy is going to be about the size of a Volkswagen Beetle or Bug. And so this one here, as you can see, has one of the nodules on it where it would kind of come off in a spike pattern, kind of showing off that. And then this one would be one of just the little dots on here rather than on the tail. So this would be just one of the central armor pieces. So there would be hundreds and hundreds of these on the Glyptodon, kind of like it was just a scale or a scoot, because it was.
Wait, what are these called again?
These are Glyptodon scoots. You can also just call it giant armadillo. I'll flip it again. But outside here, this would be where it would be facing the world. For everyone to see. And then here with the different bone, the spiral hexagon matrix looking thing, that would be where it would be attached to the body. Alrighty. Staying in the scoot category, this is a Sarcosuchus scoot. So that's a really, 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 really big crocodile. So if you guys have heard of Deinosuchus, this is kind of its bigger cousin. So this is going to be a really big crocodile that roamed the marshes and lakes about the same time that Spinosaurus would as well. So it would be one of the bigger competitors for food in the area. So this is here. It's pretty badly repaired, although it is kind of okay. But right here is a crack where it would have broken off. You can see where it's broken off there and kind of repaired there. But this is the stone that would be based on. And then this is the actual underside of the scoot itself. You flip it over, you get this really cool bone matrixy pattern.
So they just didn't chip away all the concrete that they found it in, or the
Yeah.
stone that they found it in to keep it.
To my eye, it looks like they chipped away a lot here and then realized it was going to break off if they did that anymore. So they decided not to continue with their preparation and then just kind of glued it back on. Okay. This one's fun. This is a little crayfish, not a complete one, but here you've got kind of the end of the tail. You've got some of the side panel here. This is about where its head would be right here. And then its arms come off here, and then there would be claws here as well. Now I've seen these that are 2 feet long with full claws and full, just like you could buy them out of a supermarket or a seafood restaurant, except for they'd taste like rock. But this one is a much smaller little crayfish and not as well preserved, but still very cool in my mind.
In Avery's mind.
It's a dangerous place in there. Alrighty. And then I'll take. All right. This next guy is a Gomphotherium tooth. He's one of my favorite woolly mammoth varieties. So these guys are also called shovel tuskers, as you can see with his tusks here. So this guy actually had 4 tusks. He had, well, 2 tusks and then really big teeth in the front, but he had normal tusks like a normal Macedon woolly mammoth variety. And then also these really cool protruding teeth out the bottom that he would use to dig roots and different roots and things out of the ground. And then once he got those, he would take his tongue and bring them back to these molars in the back. This is a juvenile. Some Gomphotherium teeth can be about that big as well, kind of like a mammoth. But this one is really cool. It's got the root structure at the bottom. So this is where it would go into the bone here. And then this is a little bit of polished on the top as well. That's what gives it its really nice color. All right.
Okay.
This is another one that I have found personally. This I found on my trip up to Canada in Hudson Bay. This is a huge piece of coral. So at one point, if you guys have ever seen pictures of the Great Barrier Reef, this would be like a big piece of fan coral. Well, this is the root here, and it'd be attached to a rock like this, if this was the top of the ocean, and it would be spraying out like that. So this is kind of the leftover of that. So all these little dots and nodules you can see here are where the different spores for the coral would have been and still are.
Hey Avery.
Yes.
What is your biggest fossil?
Well, you'll get to see it in a little bit, so I'm not going to spoil it.
3 more to go.
Yeah, 3 more to go. Don't worry. All righty.
We're going with this one.
Yes, we'll go with that one. So this one you got a bit of a preview of last week. This is my bison leg bone. I'll do it in sections. So you've got the top, and then it goes down to the toes, then it goes down to the hoof.
And if you've already drawn 15, you don't have to draw anymore.
At this point, if
Yeah.
you've drawn them all, you can just sit back and relax and enjoy the show for the others who haven't. So this little hole right here, this is where the tendon would have come through for the leg that attaches to the bone that would allow it to move back and forth, up and down. So that's what controls that. So that's a cool little glimpse into that. And then you can see with this bison, now, what can you guys tell me about the hooves of the bison we have today?
They're pretty much flat.
Yeah, so they're flat and they're fused together, right? So it's just one hoof bone, whereas these are 2. So this is one of the earlier forms of the bison, the hoof bone, when they would have used to have feet kind of like, well, not really like ours, but in a way like ours, where it has different toes and appendages and things. And then slowly they realized they didn't need that anymore, and it become closer and closer and closer until they fused together, and we have the modern bison we know and take pictures of today.
Evolution.
Yes, exactly. Evolution.
Science magic.
Alrighty, this is one of my favorites. This is a full bottom jawbone from a dugong. Now, a dugong is a lot like a manatee, where it's kind of like that bottom feeder low type of animal, but a dugong has a tail like a dolphin or a whale rather than a big paddle. So if you guys play Pokemon, the Pokemon dugong, it evolves from seal. It looks a lot like this guy. That was the inspiration.
That's really
I
cool.
see.
Yeah.
I definitely see the answer.
Yeah. So this guy was found in the North Sea up in England in that area. So you can see where the different appendages would have gone through the jawbone to be able to connect that way. And you can see all these different things here. So this one's one of my favorites, really nicely preserved as well. Alrighty. Last but not least, Dougie asked for my biggest fossil. Let's see. Let's show the other. Where can I see myself in the other camera? Because this one we can't use the webcam for.
So move it out here to
Must be pretty big.
Alrighty. This is a mastodon femur.
Whoa.
So the big woolly mammoth, this is its upper leg bone.
Oh my God.
So this is my biggest in my collection. This was found also in the North Sea. You get a lot of Pleistocene fossils there. So you can see this end here is cracked open, which is actually really cool for this kind of fossil because you can see all the different bone matrix inside of it as well. So that's all the different bone marrow, the different pieces that hold it together. So that gives you a really nice look into that. Here on this side, you can see where all the different tendons and blood grooves would have been in this area, connecting it to the rest of the body. And then on this side, you can kind of see the ravages of nature as the water kind of pelted this here, it broke off the other end. It would have looked much more similar to kind of like the stumpy legs you would have seen in like skeletons that you're familiar with the two knobs. That kind of would have been here, but it's a little bit weathered down, as you can see, with all the different dots and rivets and things in there. So yeah, this is my biggest one.
How did you acquire it?
This is from one of my good friends that I was telling you about.
Did you have to buy it?
I did, yes. Yep.
Was it expensive?
Comparatively, but
I mean, it's a really
we're not making any more of these.
It looks pretty expensive.
Yeah.
Your dog didn't dig that up from the backyard?
Yeah, no.
I wish.
Yeah.
That would have been a fun find.
It would have been, and then I would have looked for the rest of it. You wouldn't have gotten me out of that yard for months. But
How
yeah,
much does it weigh?
it's fairly heavy. Remember, it is rock. It's all been not as much as a Jurassic fossil would have been because it's been in the ground longer. But a lot of the different Pleistocene Mesozoic fossils, they're going to be a little lighter than normal fossils because they haven't had a lot of time to sit and get all of that rock in there. So it's probably 20, 30 pounds or so. So not light, not super heavy compared to some of the other things. But yeah, so I hope you guys got your 15 fossils out of 20. And I hope you guys enjoyed that a little bit. It was very fun for me to show you guys. And now we'll be going into our game.
Remind them about the presentation for not next week because we don't have a meeting, but the week after.
Yes, as I said earlier in the presentation, we will be doing your guys' presentations on your little fossils that you guys have in your from your home state or from wherever you guys would like about that little showcase. You don't, of course, need to have the fossil on you, but just a little picture and then information telling me about it will be perfect. Alrighty.
Zane, normally we go to breakout, but we went a little over time. ASMs, do you still have things to go over during breakout, or do you want to go straight into the game? What do you guys want to do?
Game is fine.
Since I missed 20 minutes because I had to go to cotillion.
That's okay.
That's all right. It's not a problem, Garrett.
I don't have a problem with going to the game.